Assalamualaikum warahmatullahi wabarakatuh. We're from Group 5 and we want to present our project. Our project is smart home control using sound sensor. The member of this group is myself, Muhammad Yafie Gustaff, and my friend Habibi. So first, I want to explain about the tool that we use in this project. In this project, we use lamp to be the device that we control using microcontroller, but you can change it to fan or AC or water server or any electric device that you have in your home. Next is the jumper wire are used for making connection between item on the breadboard to your microcontroller. Next is the breadboard. The breadboard is a widely used tool to design and test circuit. You don't need to solder your microcontroller to your sensor or to your tool to connect it. You can just stick it on your breadboard and connect it using the jump wire that I explained earlier. Next is a relay. A relay or a power relay module is an electrical switch that operated by electromagnetic. This relay is controlled by our microcontroller. So you can close or open the circuit currency through your microcontroller using this relay. Next is the sound sensor. Sound sensor is the module that we use to detect sound through it and change it to digital data and send it to our microcontroller. Next is microcontroller. Microcontroller that we use is not MCU. Why we use this not MCU as our microcontroller? Because it already have Wi-Fi module in it, so we don't have to buy another Wi-Fi module to connect our microcontroller to internet. So next is the design graphic. This is the design graphic that we made for this project. In this design graphic, actually we using 4-pin sound sensor module, but in the software that we use for this design graphic there is no 4-pin sensor module. There is no 4-pin sensor module in the software, so we using the 3-pin sensor module, but it's still the same. So in here in the relay, the connection is in connect to the D1 and the ground pin connect to the ground pin in this microcontroller, and the VCC pin connect to the 3-volt power pin. And in here the lamp that we use connect it to the relay and then the power. Next for the sensor is the D0 pin connect it to the A0 pin, and the plus pin connect to the power pin, and the ground pin connect to the ground pin. So next is the flowchart. Here first we start and then we input sound from our sound sensor and then processing the sound, and in here we use a switch case. In the case 1, if I equal to 1, if yes, then the relay on and the lamp automatically turn on too, and then break, and then we output value and graphic and then display it on our IoT platform and end. And if I equal to 2, then we go to the case 2. In the case 2, if I equal to 2, then relay turn off and then the lamp turn off too and then break. And if I equal to 3, then we go to default statement. But here in break, then we output the value and the graphic and we display it on IoT platform and then go to A. Here the A we go to N. And in the default statement, if I equal to 3, then we go back to the case 1. So next, my friend Habibi will explain about how it works and the program code.
Okay, Assalamualaikum warahmatullahi wabarakatuh and welcome back. Now I will continue this presentation. Now we'll discuss about a program code in here. So in here, I'm using a Arduino IDE, honestly. So the program code in here, the first I'm using a include changer because on this project I'm using a IoT platform. So the name of IoT platform is changer.io. You can check on the website, and in here I'm define username. My username of the changer.io is inceptions, and device ID is like a unique ID on your dashboard, and my ID is not MCU, and device credential like device ID. And in here, because we connected on either platform, so we need connection internet. So in here I'm using my device, because in here I'm using a hotspot. I'm tethering my device on my device IoT, and you should define your SSID over here, and my SSID is Rewaki Kwewai. In here, you should define your password Wi-Fi in here. So my password is 123 QWERTY 456, and continue. I'm in here. I'm using a const integer for your where you should declaration your IoT prof your device IoT. In here I'm using a zone sensor. I'm input from the pin A0, and in here I'm using an integer red zone and const integer relay pin number 5 or digital number 5. And in here I'm using an on is high, off is low for the relay, honestly. And in here I'm using a range is 100. So and we're going to file setup. In file setup I'm using a serial begin, because why I'm using a serial begin, because I wanted the display on the serial monitor on the application Arduino IDE, and I'm using a pin mode. Zone is input, so the sensor is for the function of the sensor is input, and the relay, the function of relay is output. And if the sensor detect a zone, and the relay will be output the program code. And in here honestly I'm using two widget on the IoT platform. So you can honestly you can use maybe 3 or 5 the widget on the IoT platform, but honestly I'm just use 2 widget on this project, is a graphical and a sensor value. And we're going to void loop. And void loop in here I'm using a read zone is analog read zone. So in here I'm using a serial print line for to print the value on the terminal sensor, and the logic is if the read sensor is up to the 100 is will be I++. So that's a logic, and in here I'm using a switch for logic I in here. And case one, if you flip, maybe you can make a sound like you can do it, or you can make sound by your mode. And in here, if the flip one, or you can make on the first time, the relay will be on. The relay will be on, or honestly, relay will be off, and the light will be on. And if you can do the second time, and the relay or the light will be off, and the brick in here is a stop. So what happens if I want to turn on the light again? So in here I'm using a logit I is 3. If I is 3, or maybe we back again is case 1 is you can turn on the light, and 2 is turn off the light. And what happened if I want to turn on the light again? So in here I'm using a I is 3, and we'll be back on I is 1. We'll be back, and that's a system looping for this project, and we'll be looping again. And now the program code is done, and I want to explain to you the IoT platform and what the implementation, the device from this project. So keep watching, and we continue to implementation.
Okay, for this time I want to show you how to implementation of this device, but before I want to show you the tools of this project. In here I'm using a sound sensor, and I'm using a billboard over here, and I'm using a Node MCU, and in here I'm using a relay, and the last I'm using the lamp. And for the question how to implementation this device, if you want to turn on the light, you can make a sound whatever what do you want, and you can do like me is turn on. And if you want to turn off the light, you can do okay. And in here I want to show you the IoT platform over here. Okay, this is IoT platform honestly, and in here you can control your device over here by your IoT platform over here. And this is a status of your device. Just the Tinger.io detect this only one device to connect it on this IoT platform. And over here you're going to dashboard, and the dashboard you can going to your dashboard. In here I'm using a value number value in here, and I'm using a graphic for see my device. And the value of my sensor in the device is 21. This is a normally value is 21, and in here you can see the graphic on your value. And honestly you can change the option over here, and in here I'm using a second because I need to real time of the value over here. And honestly you can use the other widget over here. In here in the Tinder.io so many widget over here, but honestly I'm just only use a two widget over here, is a graphical and a value over here. So this is a Tinder.io or IoT platform, and thank you very much.